Welcome everyone to the 3ds Max Basic Modeling online class. I am your instructor, Li Ruijing. In this lesson, we'll use the same concept art as in Project 1, but this time, we will create the high poly model of the token. Experience the typical high poly prop workflow of a next-gen model artist.
Teacher, what are the workflow differences between building this token's high poly model and the previous low poly model?
Let's start with the high poly workflow in 3ds Max. First of all, build the mid poly model. Secondly, add supporting edges. Thirdly, apply the Turbo Smooth modifier to obtain the high poly model. So the high poly model is derived from the mid poly model. The steps for making the token's mid poly and low poly models are largely the same. The difference lies in the edge flow approach between low poly and mid poly models. Low poly edge flow aims to reduce the polygon count. It must comply with the project polygon budget defined in the specification. Mid poly edge flow aims to make adding supporting edges easier. There is no strict polygon budget, so, with this goal in mind, when we create models, we need to pay attention to the following points. First, keep faces as quads wherever possible. This facilitates edge loop control. Second, try to separate the model's components. This also helps with edge loop control. In the token High Poly Virtual Simulation Lab, we can see that the token High Poly model's components are separate. Now, let's try it out together. Open 3ds Max and follow the method taught in the token Low Poly project. Place the token's front reference image in the viewport. Trace the token outline with a spline, using corner vertices. This step is largely the same as the token's low poly blocking. What you need to pay attention to is, when placing vertices, you're no longer constrained by the polygon count. Vertex spacing can be tighter. Proceed to creating the polygon patches. Press Altitude plus X, see-through, to make the patches transparent. Right-click to enable the Cut tool. Start connecting the edge segments. Of course, you can also use vertex selection. Press Ctrl plus Shift plus E to connect the edge segments. Remember, keep the resulting faces as quads wherever possible. Sharp corners like these should remain triangles. Keep the rest as quadrilaterals as much as possible. You see, after connecting here, the corresponding vertices above and below might not match exactly. First, use the Move tool to adjust these connected vertices. Then enable the Cut command. Use Cut from vertex to edge to add new vertices along the edge. This ensures the resulting faces stay quads. So when connecting lines, if you can't find a matching vertex, you won't be able to form a quad. You can use Cut to insert vertices and reroute edges to create new quads. After using the Cut tool, reposition the new vertices. Make sure they match the token's concept art. The following steps are the same. Let's quickly go through them. Everyone, take a look here. While cutting and connecting vertices, a visual glitch appeared here. It probably happened because the Cut tool didn't snap to the target vertex, causing two overlapping vertices at that location. Select and move one vertex, you'll see there are two overlapping vertices. Box select both, at the vertex sub-object level, you'll see two vertices selected. Then right-click and choose Collapse. Collapse the two vertices into one. When using the Cut tool, you may occasionally encounter this issue. Always check for overlapping vertices and collapse or weld them. The following connection steps are the same. Here's the final result after connecting. Pay attention to these 3 points when connecting. 1. Keep faces as quads whenever possible. 2. If there are no matching vertices, use the cut tool to create new quads. 3. When cutting, watch for overlapping vertices and collapse them into one. After connecting the outer contour, use the cut tool to connect the internal transition structural edges. Place each cut vertex on an edge segment, not on a face. After cutting this segment, if no vertex matches the concept art structure, move it to align with the concept art. Take a look. A new triangle appeared because of the cut. Use cut to reroute the edges of this triangle. Just delete the extra edges. Then move the new vertices to make the edge flow smoother and more even. The following structural line cutting operations are the same, so I won't demonstrate them one by one. Here's the final edge flow result. There are 3 things to keep in mind when cutting structural lines. Firstly, keep faces as quads whenever possible. Secondly, ensure each cut vertex lies on an edge segment. If it's not aligned with the concept art, use the Move tool to align it. Thirdly, always check if new triangles have appeared. You can optimize them into quads using target weld, edge deletion, or collapse. After finishing, switch to the edge sub-object level. Double-click to loop select the edges that define the token's thick structural parts. If too many edges are selected, hold altitude to deselect. Deselect the sharp corner edges here, so they won't be pulled up during the thickening step. Press P to switch to the perspective viewport. Move the selected edges forward along the Y-axis. Give it thickness along the Y-axis. Then go to the polygon sub-object level and box select all faces. Drag to adjust the panel width. Drag to make it 2 columns. At the polygon level, find smoothing groups. Clear all smoothing groups. This makes the structure clearly visible. At sharp corners, move the vertices slightly along the Y-axis. Make it gradually taper to a sharp point. After finishing, rotate to check. Now exit the sub-object level. This completes the yellow portion of the quarter of the token. In the hierarchy panel, enable Effect Pivot Only. Reset the model's X, Y, and Z axes to 0. In the 6th toolbar on the right, enable Reset Transform to reset the selected object. Next, go to the Modify panel. Right-click and convert to Editable Poly. Add a symmetry modifier to this model. Set mirror axis to X. Add another symmetry and set mirror axis to Y. If the model doesn't appear, enable Flip. Like this, we use a symmetry modifier. It turns the quarter segment into a complete model. Go to the Editable Poly level. Enable Show End Result. Press F to switch to the front view. Let's work on the red planar section. We'll still use splines for blocking. You only need to outline half. Make it a closed spline as well. Set the X value to 0 for the 2 vertices that must be left, right symmetric. Then convert it to Editable Poly. Use cut to connect the polygon patches into quads. Enable effect pivot only. Reset the X and Y axes to 0. Orbit to check. This patch is also 1/4. Go back to the Modify panel. First, drag the entire patch forward along the Y-axis. Reduce the gap in depth relative to the gold part. Then enable Effect Pivot only again. Reset the Y-axis to 0 again. Go to the Utilities panel. Click Reset Xform, then Reset Selected. Then right-click and convert to Editable Poly. Apply a symmetry modifier to the model. Enable the X and Y symmetry axes. If the model is invisible, enable Flip. OK, the red patch is done. Press F to switch to the front view. Check the thickness where the two models meet. It looks too thin. Go to the gold part and switch to the edge sub-object level. Double-click to loop select this in a ring of edges. Rotate the viewport a bit. Drag this ring of edges forward along the Y-axis. Align it to the red part. Press F to switch to the front view. Now, the thickness where the red and gold parts meet is just right. Now assign different materials to distinguish the parts. Assign a gold material to the gold part. Assign a red material to the red part. Then apply a black wireframe uniformly. Next, use the same method to build the fire character model. Step 1. Use splines to outline the fire character. Consider whether the left, right corresponding vertices can be connected into quads. Step 2. Convert this closed spline to editable poly. Move it out from the model and use Attach to make it a separate object. Step 3. Switch to the vertex sub-object level. Connect the fire character into quads. Pay attention to the bend position. Place two adjacent vertices at the bend. This way, the bend won't be rounded off easily during Turbo Smooth. Keep the connections as quads in other areas whenever possible. Delete any extra vertices using backspace. Here, repeat the connection operation. Let's fast forward and check the connected edge segments. Step 4. Select all polygons and use bevel to create thickness. From the front view, check for any overlaps. Make slight adjustments. The mid-poly model of the fire character is now done. Now, let's create the rope's mid-poly model. Each visible volume of the rope can be separated into different objects. The upper and lower rope loops are 3 separate circular rings. Adjust the ring's angle and shape according to the concept art. Make the middle section the same way as the low poly rope. Use splines for blocking, then enable rendering and set the shape to cylinder. Refer to the side view of the concept art. Adjust the rope's shape from the side. Delete the cross-sections at the top and bottom. The more complex part is the rope tassels. Let me demonstrate it. Use a Biia vertex spline to block out 3 cylinders of different shapes. Set the radial sides to 4. Adjust the shape of the 3 cylinders from every angle. Biya vertices can be rotated, moved, and scaled. The vertex above is currently a corner vertex. You can also right-click to convert it to a biya vertex. Move it slightly to better match the rope loop's position. In Editable Spline, find the interpolation rollout. Set steps to 2. This reduces the horizontal segments. This makes further shape adjustments easier. After adjusting the interpolation, right-click to convert it to editable poly. Press Altitude plus Q to isolate selection, then use Attach to combine them into one object. Collapse the bottom face into a single vertex. Delete the faces inside the upper rope loop. This deletion isn't to save polygons, it's to get a cleaner turbo-smooth result. Exit isolation, then double-click to loop select the horizontal edges. Scale them slightly. After adjusting, press W to activate Move. Use Move in screen space to adjust the vertex position. Open the Reference Coordinate System drop-down at the top of the viewport. Change it to Screen. This lets you move the vertex using the screen axis. You can move it in the current view. Move the vertex to the optimal position. Press Altitude plus Q to isolate, then rotate to check. This completes the rope tassels in the mid-poly model. Now select all rope objects. Assign a blue material. Apply a black wireframe. Assign a yellow material to the fire character. The token's mid-poly model is now done. Task completed. Do you now understand the differences between the token's mid-poly workflow and the low-poly one? Then, in the next class, we will use this mid-poly model to create a high-poly model. That's all for today's lesson. See you in the next class.